This lesson shows how we can use pattern blocks to represent fractions. Pattern blocks are wooden or plastic blocks representing different polygonal shapes. They are commonly used in geometry for activities like tessellations. We're going to show in this lesson how to use them to represent fractions, and then in later lessons we'll look at adding, subtracting, multiplying, and dividing fractions, and how we can represent them using these blocks. If you do not have access to the physical blocks, you can download this handout from Blackboard and cut out copies of these shapes. They will be helpful when doing homework problems or following along in the activities for the lecture notes. These are the four pattern blocks we'll be using to represent fractions. We need to understand how they fit together. The yellow shape is a hexagon, namely a six-sided polygon, specifically a regular hexagon. The red shape is a trapezoid, a quadrilateral with a pair of parallel sides. Two trapezoids form this hexagon. The blue shape is a parallelogram. It is a quadrilateral with two pairs of parallel sides. Three of these parallelograms will form the hexagon. And lastly, the green shape is a triangle. Six of these triangles will form the hexagon. This is actually an equilateral triangle. All three sides are equal and all three interior angles are equal. These pattern blocks do not have fixed values. Whenever we represent a fraction, we need to first define what a whole is. If a trapezoid represents a whole, or 1, then a hexagon is made out of two trapezoids, so a hexagon would represent 2. If a trapezoid represents a whole, or 1, then since we can form a trapezoid from 3 of these triangles, each triangle must represent 1/3. If a trapezoid is a whole, we can't fit a whole number of parallelograms in a trapezoid. One parallelogram is smaller than a trapezoid, 2 would be larger. But since we can make a parallelogram out of 2 triangles, and each triangle represents 1/3, then a parallelogram would represent 2/3. We can also see that 2/3 of the trapezoid is covered by the parallelogram. The part left over uncovered is this triangle, which is 1/3. If a trapezoid is a whole, or 1, then this shape can be made using 2 parallelograms. If each parallelogram represents 2/3, then together they represent 4/3. Or we can make this shape using 4 triangles. If each triangle is 1/3, then this shape equals 4/3. 4/3 is also equal to the mixed number 1 and 1/3. That would be one whole trapezoid and a triangle, which is 1/3. For the next part of the lesson, suppose 2 hexagons are one whole. If 2 hexagons are one whole, then one hexagon would be 1/2 of that, or 1/2. 4 trapezoids would make 2 hexagons, so one trapezoid would be 1/4. 6 parallelograms would make 2 hexagons, so one parallelogram would be 1/6. 12 triangles would make 2 hexagons, so one triangle would be 1/12 of a whole, or 1/12. If 2 hexagons make up a whole, then 2 parallelograms would be 2 times 1/6, or 2/6, which is also equal to 1/3. 2 of those parallelograms would occupy 1/3 of the 2 hexagons. We could make 2 more copies, and the 3 of them together would cover the 2 hexagons. Since one trapezoid is 1/4, 3 trapezoids would be 3/4. If 2 hexagons represent a whole, to make the fraction 5/6, we could use 5 of the parallelograms, since each parallelogram equals 1/6. To make 5/12, we would use 5 triangles, since each of the triangles represents 1/12. If 2 hexagons represent a whole, and we want to represent the fraction 2/3, we don't have a single block representing 2/3, but we can write 2/3 as the equivalent fraction 4/6, which would be represented by 4 parallelograms. We can also represent 2/3 as 8/12, which would be represented by 8 triangles. Each of those has the same shape. Each of those would represent 2/3 of the 2 hexagons. Similarly, if 2 hexagons represent a whole, to represent 4/3, we can use the equivalent fraction of 8/6 and form a figure with 8 of the parallelograms. 4/3 is also equivalent to 16/12, so we could use 16 of the triangles to represent 4/3. Again, what represents a whole varies from problem to problem. We can reverse this process. If we're told that 2 parallelograms represent 2/3, then a whole would be 3 parallelograms, or a hexagon. If we're given 3 trapezoids and told that 3/5 of a whole, then a whole will be made up of 5 of those trapezoids. There will be more lessons involving adding, subtracting, multiplying, and dividing fractions using pattern blocks. You may want to review this video to see how we define the fractions.